but never hurts to take a look. All right, so you have a nice little blurb here. Rational function and the end behavior model function behave the same way as each other. As you look at large values of x in the positive or negative direction, so extreme values. We get the end behavior model function by dividing the leading term of the numerator polynomial by the leading term of the denominator polynomial. Okay, so if you're just looking for steps, that last little bit there is really all you need, this guy here. It's telling us that if we want an EBM, end behavior model, all we're going to do is take the term with the highest power on the top, divide it by the term with the highest power on the bottom. So y would be equal to x over x squared, which simplifies down, because you always want to simplify down, to 1 over x. Right, the same idea would hold true for the second example, except the terms are not in an order that you would really like it to be in. So I'm going to take this guy divided by that one. So my EBM, and you can skip steps on this. All I need is the EBM. Would be y equals negative x squared over negative x, which cleans up to just y equals x. All right, so let me show you what that looks like on the calculator. The whole point behind this end behavior model is to work with a simpler function. It's telling us that instead of working with this complicated function, if I work with a simpler function, I could find the limit of this as x approaches infinity, and it will be the same as the limit as x approaches infinity for this function. All right, so you can look at it. The first example gives you a nicer, kind of more satisfying look. Let me just make my window a little bit better. So something like negative 4 to 4. Okay, so we have our two graphs. They look incredibly different for small values of x, so by the y-axis, but as you feather out towards negative infinity or positive infinity, they become indistinguishable from one another. Okay, so this is the foundation of infinite limits. Also, a little review of horizontal and vertical asymptote rules, because it's actually through the end behavior models that we get the concept of horizontal asymptotes. All right, so if you actually know how to find the limit of an end behavior model, you could find the horizontal asymptote without memorizing rules. I mean, you're welcome to memorize them, but you don't need to. Okay, so it's kind of cool in that regard. I could show you a quick example. Let's say you have a function of x over x squared plus 1. And we need to find the horizontal asymptote. Horizontal asymptotes only apply for extreme values of x. So it's basically talking about the behavior of the function as you go out from center. So if I find the end behavior model, the EBM, which is what you would get if you divide these two guys, y equals 1 over x, just like that first example, and then find the limit as x approaches infinity of 1 over x. Through direct substitution, you get 1 over infinity, right? Right? Replace the x with an infinity. What does 1 divided by infinity approach? What number? 0. All right? Because 1 over infinity is not equal to 0 because infinity is a never-ending system. But as you increase the bottom number of a fraction, the value of the fraction gets smaller and smaller and smaller, approaching 0. So what that tells me is that my horizontal asymptote is actually y equals 0. Another quick one. Let's say if f of x equals x squared minus 1 over x squared plus 1. What's my end behavior model here? 1. All right, so if I were to find the limit as x approaches infinity of my end behavior model, it should be the same as the limit as x approaches infinity of my original function. What is the limit of a constant? AKA, what's the limit of 1? Whenever you're looking for a limit, you're looking for the y value that you're approaching as x goes to a particular number. This is telling me that y is 1, no matter what x is. So for all values of x, y is equal to 1. So the limit of that constant would be the constant itself. All right? If your y value is not changing, that is your limit. So horizontal lines are kind of the nicest thing ever because it is its own limit. So what we get from this is that we have a horizontal asymptote, y equals 1. All right. So long story short, those rules, remember the power rules that you had to learn from pre-calc, where it's like if the power on the top is more than the power on the bottom, the power on the bottom is more than the power on the top, the powers were the same, you memorize all these relationships to come up with the horizontal asymptotes. You don't need to do any of that. You just need to know what the end behavior model is and plug in infinity. So if you had one where the power was more on the top than it was on the bottom, then when you plug in infinity, you're going to get infinity. And if something's going to infinity, it's never leveling off, in which case it's telling us that there is no horizontal asymptote, right? So basically wiped out like a 2-day lesson in pre-calc or gap, depending on where you came from. Totally useless. You recognize the notation? So you look at the c with a minus after it. That's saying the limit as x approaches c, some constant c, from the left. So from the left-hand side. Which is telling us that the action is starting on the left and going to the right.
Wait, how do you do it? It's from the left?
That little symbol. All right. If you have a plus sign, that's telling us that we're starting on the right and working our way to the left. All right, so that little notation is important. If there is no symbol, it's telling us that we're going from the left and from the right, and we're seeing what the relationship is. Oh, yeah. All right, so if it just said find the limit as x approaches c, it's telling you on your own, figure out the limit from the left and from the right and see if they're the same. If they're the same, you got the successful high five, that's what your limit is. If they're not the same, then you have the missed high five and the limit does not exist. All right, so that's visually, but if you want to do it analytically, you want to use the end behavior model. So what's my EBM here? Y equals, or bless you, we're dividing these two guys, right? Y equals 5. So I'm looking for the limit as x approaches infinity of my end behavior model. Limit of a constant is a constant. If you want to verify it graphically, I encourage that. That's a good idea. Nice little mobile self-checking device. 5x plus 4 over x. Put in, again, in your delta table, so second window, put in your delta table something really big.
So how's it different?
And see where it's leveling off. It seems like it's level, the y values are leveling off at 5 as you increase to infinity. You want to put your table start at 0 and your delta table at something really large. And then when you go into the table, you should be going by whatever increment you set up. Just a little recommendation. Second window, 0, 1 when you're done with the problem. Puts it back to the standard way of representing it. Right. This way you're not kind of thrown off when you go into a table looking to like plot a graph or something like that. All right, but that's the general idea. So let me do one that'll give us a different answer. So number 4. So folks, just for like a point of reference, I'm only going to be up here doing this like 20 times this whole year. So can you just do me a favor and hold off on the socializing until after I get through my spiel. And behavior model here would be what? And it'll almost never be for the full period. So limit as x approaches infinity of 1 over x, which is the same as 1 over infinity. We're going to what? 1 over infinity is approaching what? 0. So we now know the limit. One more, last one. Because as you increase the denominator of a fraction, the value of the fraction gets smaller and smaller, approaching 0. All right, let's do number 5. My EBM would be what? Y equals x. So I'm looking for the limit as x approaches negative infinity of x, which would be what? It's like the easiest question out of everything that we'll do this year. Negative infinity. Yeah, it's direct substitution, folks. It's not a trick question. No, it's just that is what it is. Now, if that were in a fraction, that's a different story, but it's not. It's just negative infinity. Right? So this is telling us that as we go out to negative infinity in x, so as we go to the left, the graph is going to go downward forever. Right? And you can draw that conclusion just by finding the end behavior model. Pretty powerful stuff. Bless you.